Welcome. So you should all be able to see and hear me right now. Just let me know if you can't hear me. If you're here, please say hello in the chat. How this works is it's both ways. So I need you talking in the chat as well as me talking as well. So if you're here, just say hello, and we'll get started shortly. Awesome. Okay, let's get started then. So we've got a decent number of people here. That's excellent. All right, so we're starting early this week so that we can have a look at the assignment. We're going to go over some of the stuff we've already talked about last week, just so that everyone's on the same foot, and then we'll get into the deeper stuff that we didn't get time to cover last week, but we will cover the entirety of the assignment. So for anyone not aware, there is an assignment that's due next week, Sunday. It's a very short assignment, and the main purpose of it is to convert between degrees Celsius and degrees Fahrenheit, and Fahrenheit to Celsius. We're using these two formulas here, and the whole problem is described throughout the assignment. And there is a rubric, which we can also have a look at today. So I'm going to close that for now, and then we'll go through everything. All right, so let's go up a little bit. So first things first, I'll just reiterate some of the things that are on the constraints. A lot of students tend to skip past the constraints, and I noticed this in most years. This also applies to exams. When you're doing exams, make sure you read everything, because I see it quite often that assignments, exams, a lot of places where students lose marks are for places that they shouldn't if they just read. So the first one here is that we're using user input. So nothing should be hard-coded, meaning if you've got the degrees values that are going to be printed, or the Fahrenheit values that are going to be printed hard-coded, so that let's say you've got 10, 12, 14 written somewhere in your code, then you're probably going about it the wrong way. This is a user interface, and the user gets to decide. Formatting needs to be specified as specified. Don't deviate from the formatting. As you know, we did Printf last week, and so we are looking for the formatting, especially the tables. Okay, the tables will be tested against automated test cases. Text to user needs to be easily understandable. You can change some of the text, just don't add extra new lines or anything like that. So if you want to change text slightly, you can, but don't add extra text. Program must print your student number, name, and the assignment number as specified. We'll have a look at that in a sec. And it must print the password as specified. And most of you have already seen this. Types should be used appropriately. So here we don't want to waste memory, and we don't want to cause huge amounts of floating point operations. So floating point arithmetic is slower. And so we don't want to see every single variable declared as a double. Okay. The next thing is you don't need functions. My recommendation is, even if you know functions, don't use them. They're not really necessary for this small of a program, and we haven't got much repetition in this program where they'd actually be useful. in terms of optimizing your code. They might help in terms of breaking up your code, but it's not actually going to make it any faster. Okay. You must use comments to explain significant lines of code. So if something isn't obvious, you need to put a comment there. We don't want to see comments like variable A is being declared. We can see that, okay? Interesting comments would be things like units, things like explaining the math, explaining what's being iterated. So don't explain the code itself, explain what's happening. We're testing on what you know in this subject only. If you're using something else outside of the subject, ask before you use it. The code must be done using ANSI and must compile on Let's CS5, blah, 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 using GCC. Okay, so that means it must work on our system. You must not use goto in the assignment. We're not going to use goto for the entirety of this subject. And you're only allowed to include the standard.io.h header file. No others. Do not use conio.h. You will lose 60% straight away if you do. And if you use both goto and conio, you will lose 100% straight away. Get 0. The next thing here is the code should be around 30 to 70 lines without the bonus. So there is no bonus this year, so we don't have to worry about that. But if your code is significantly larger, you might want to consider your approach. This is just a guide, okay? So if you're doing everything normally and you're not using functions and stuff like that, and you've got 150 lines of code, that's significantly larger, okay? If you're being extra careful and you've got a couple of extra lines and your code is 90, don't worry about it. That's perfectly fine, okay? Significantly would be something like double, okay? So don't stress if your code is a little bit longer just because you've been extra safe and you've declared some extra variables. But if it's really, really long, then you've probably gone about it the wrong way, okay? All right, so solve the problem by implementing a program using C code. The code must be documented using comments. Now, the reason that the code must be documented using comments, there's 2 reasons. Firstly, it's good practice. But the second reason is that in previous years, we got you to write a report. And that's where you showed your understanding of the code. Instead, this year and last year, we did the documentation in the code itself. So it should be equivalent to a short 200-word report, the comments in your code. All right, if that all made sense, just say yes in the chat and we'll move along to the first part. So for how this works, just say yes and then we move along. Beautiful. If there's anything that you're stuck with, don't be embarrassed to ask. Just ask and we can go over it slowly. All right. So this part here was the part that I asked most of you to do earlier on in this subject. If you didn't, don't stress. This shouldn't take you too long to implement. So the first step here is to comment at the top of your file the program's purpose. So explain the domain, what it does and what it's meant to do. Mention the inputs and the outputs. So we've got what coming in, we've got user inputs. What have we got coming out? We've got a table that's formatted. So that's basically the program's purpose. And then how it's implemented. So how it's implemented, you should use the lecture knowledge and describe the steps. So did you use an if statement? Did you use a do while? And so on. What's the zeros? I'm not sure. So just put a couple of steps explaining, no, don't be sorry. Just put a couple of steps explaining the process. You can break it down however you like. Now, let me just write this to the chat. All right. The next part is fairly simple. This is just a printf to the screen. There is no need for any variables here. Just print it directly to the screen. So printf, double quotes, star, star, your student number, not John Smith's, John Smith, okay? You don't need %s, you don't need anything else, just print it directly to the screen, okay? So you do not need to create strings. We haven't really done many strings yet. We did need it for the second lab, but we're gonna come back to that in about week 7. So we don't need to see strings in this assignment. We're not marking them. So just put that directly into a printf and print it out with your student number and your name and your, well, everyone's going to have assignment 1. Don't forget the double asterisks as well. So it mentions there that it must be enclosed in double asterisks. We need that so that we can parse your files. Okay, so please include that, or else we'll have to look at yours just very differently. The next line is the password. All you need to do is go to that link and copy word for word what's there. Okay, don't worry what it's about. We have a reason we've included that. Just copy it and include it. You need to include both of these or you do get 0 for the assignment. Okay, so do not skip. That's why it's in red. Okay, if you forget it, you will get 0. And that's why it's right at the top, right at the start. Okay. The next line here is asking the user which table they would like to create. And this is just a printf as well. Now, if you've read the problem, we've got quite a few steps. So the next step is this repetition of the same step in step 4. Now, there is 2 ways to go about this problem. We can break this up into 2 problems and treat the problems as a modular solution where we deal with this by itself and then deal with the printing the tables by themselves. Some students have gone with this approach. Some students have gone with a big block. The big block solution is a little bit more optimized. This solution is a little bit more modular. Okay, so meaning you could put other blocks in and you could change things around and change the blocks. Okay, so if that doesn't make too much sense, don't stress. We're going to go with the more modular approach in my examples here. Okay, if you are a bit ahead, you'll know what I'm talking about. All right, so on step 4, we're asking the user if they would like a Celsius table, a Celsius to Fahrenheit table, or a Fahrenheit to Celsius table. Now, this here, ignoring the tables, we get an integer value from the user. Okay, so we know that we need, let me give myself a little bit more room. We know that we need a printf asking the user which table they'd like to create, and then we need a scanf to get those things. Now, at this stage, we only need 1 variable, and we're going to declare this variable right at the start of main. Okay, so we've got int main, blah, blah, blah. And a good name here might be something like choice or option or table type. So you can decide on that. I'm just going to declare it as an int, and I'm going to call it something short. I'm just going to call it choice in my example, but you can call it whatever you like. Now, we talked about this last week in our video. we don't want to declare everything up the top, okay? We only really want to declare stuff where it's used, and we'll see this a little bit later, okay? So don't just go ahead and declare everything at the top straight away. All right, so we have our printf and scanf. Now, with our scanf, don't forget you need this ampersand symbol. We're going to learn what that's doing a lot later in the subject, but you just need to know to include it for now. Okay. Now, here we've got another problem. It says if the user does not enter a valid value, i.e. 1 or 2, the program should print the following and reprint step 2. So you can see here that we've got our step 4 and it's doing it multiple times. Now, if you were designing this program from scratch and you are building this yourself, you may want to skip this validation step just so you can test that the logic works and then come back to this. And that's an option for you as well if you want, because while you're testing, you're going to put in correct values anyway. But we're going to start with this now. But if you wanted to skip this, you could by just having the printf scanf and then go to the next steps and then come back to this, okay? Because all this is doing is if the user enters something wrong. And while we're testing, we're probably going to enter things that are right anyway. All right, are we all good up to now? Is there any questions? I'll explain step 5, so that's to come. But if you're understanding so far, just say yes. Good. Good, yes. Beautiful. All right. Now, when we have a repetition, we need loops. Now, usually we consider 2 problems with loops. And we've got counting, or we've just got until it terminates based on some kind of selection. So here we're not doing any counting. So this means that we're going to use either a while loop or a do while loop. Now you might have not seen these yet, but basically how these work is we have while, then we have some condition, and then we have some braces. A do while looks very similar in that we have this. Now, common mistake with a do while is that there is actually a semicolon down here. Okay, so don't forget about that guy. Now, what's inside here? It's some condition. Okay, what's in here? Some condition. So these loops will keep looping until this condition is false. Okay, same with this one, exactly the same thing, except for one difference. So this while loop will run 0 to n times, okay? So that could be infinity times. And a do while will always run once, okay? So you can think of a while loop. Let's say I ask the user how many values they'd like to add up, and they enter 0. Well, if they enter 0, there's no point going in the while loop and adding the values up. Where if I ask the user something, and let's say it's a menu for a game or something, I want to show them at least once, and so that'd be a do while loop. Okay. Now, the condition basically can be anything that evaluates to a number, and we usually look at Boolean expressions using relational operators. So anyone unaware, if they haven't watched the video yet, Basically with ifs, whiles, all they're looking for is a value other than 0, okay? Because 0 is false and anything not 0 is true, okay? We don't have to worry about this too much in this one, but it is handy to know because we can do a lot of optimizations in C with our conditions that you can't do in other languages because of that. All right, so I could say something like, if I wanted to compare a user's input, I could say while input not equal to 1. Oh, 1, okay? So this is an integer here. And same down here, I can say while input is not equal to 1. Okay? You can chain these together using ands and ors. Okay? Now, you have to be careful about this, and maybe we'll have a look at an example without giving away the solution. All right, so yeah, let's do an example of an and and or. So let's say I want to keep looping while, let's say, x is greater than 3 and x is less than 0. Okay. So here we've got x less than 0 and x greater than 3. Now, here, should we use an and or an or? So that's a question for you. So we want to continue looping while x is less than 0, and also when x is less than 0. So here we'd have to use an or, because x can't both be less than 0, oops, and greater than 3. So it can't be and, because that would mean that both of these need to be true, and this would fail. Okay? Think of your number line. Okay? So it has to be an or. Okay? Because it's either one of these two. Okay? It's either before the 0 or after the 3. Where if we had something like we want to continue while x is greater than 0 and x is less than 3, this would be an and. Okay? Because x can both be greater than 0 and less than 3. Okay, so you need to be careful with your ands and ors, and you need to think about which one you need. Have you got 2 independent cases or not? Okay. So when we're going to use or, usually it means that only one of them can be true and not both at the same time. And if both at the same time are false, then we usually exit. So you need to have a think about how you're going to implement that with your inputs. Okay? Maybe we'll come back down to that. Does that make sense? I know a lot of people answered and, but if you think back to when you did the number line back many years, if I pick a number in the middle here, it's both greater than 0 and less than 3. But when I got something like this, this number here, it can't be both. It can't satisfy both. I'm going to repeat the same about and not. Okay. All right. So if I wanted to, if let's do an example. So if I have x is 6, okay, and I've got the condition that I want x less than 0 and x greater than 3, okay, this here can never, ever, ever be true, okay, because x can't both be greater than 3 and less than 0 at the same time. And we know that from mathematics, okay? So we've got x is 6. It can't both be in this part and this part at the same time. So we know that this has to be an OR. If this is what we're looking for, that green locations on the number line. We're saying x is less than 0 or x is greater than 3. However, if we're looking for both to be true, so say we've got the case x is greater than 0 and did I stuff that up? I think I did. Oh no, I didn't. And x is less than 3 and we have 2. So if I use actually, that's a perfect example. So if I leave the 6 there, if I used an OR here, I'll do a green, because the green's good. So what you want is this here. Now, if you use an OR here, x is greater than 0. That's true. But x is not less than 3. But because we used an OR, we've said that this whole condition is true. And 6 is over here, but we only wanted values between here and here. So we'd actually want to use an AND in this case. Okay? So if it's bounded, then you want to use an AND. Okay? Does that make sense? So I repeated it in a slightly different way, but you need to be careful with ANDs and ORs. And maybe we can have a look at an input example as well. Actually, let's do an input example. All right, so let's have a look at an input example. So let's look at 2 discrete values. And I'm going to call them 8 and 9. Okay, so I want to continue while the user enters at least one of these 2 values. If I want to enter one of these 2 values and continue looping while the user enters either one of these, should I use an AND or an OR? So the loop keeps looping. If they enter an 8, then I keep looping. If they enter a 9, I keep looping. So if they enter either one of these, do I put an AND or an OR? So this would have to be an OR because you can't have 8 and 9 at the same time. So you've got these two discrete cases. So here it'd be input equal to 8 or input equal to 9. Okay. Now, notice here, this is another common pitfall. That there is equal. Okay. So we've been using assignment so far. This is our equal. Now, if I wanted to continue while the user didn't enter an 8 or a 9, what would I use then? So I want to continue while it's not 8 and not 9. Would I use an or an and? I've got a bit more room. Maybe what I'll do is we can try it both ways. What are we getting? All right. All right, so let's try it both ways for demonstration, because I think some people are getting a little confused by this. And if you do get confused by some of the Boolean logic, just test it and see what happens on a piece of paper rather than jumping straight ahead into the code. Let's just get rid of some of this stuff. So we're going to try two different versions. We'll try an OR and we'll try an AND. So let's say the user enters a 8. Okay, so an 8 should come out false. Okay, because we want to continue while it's not an 8 and not a 9. So if we have a look here, input not equal to 8. Well, what's that come out as? False or true? I'll let you guys do it. So if we got an 8 and I had input not equal to 8, what do I get? Okay, so we get a false, okay, which is a 0. Okay. So don't get confused by the not equals. I noticed some people did previously. And the other thing I'm trying to encourage is you using the chat, even if it's an obvious answer, just use the chat because it helps me. So then we've got input not equal to 9, which is true. Okay. And then we've got our OR. Okay. So this is the same for this. We've got a 0 and a 1, but we've got an AND here. Okay. Now, the OR comes out as true, where the AND comes out as false. Remember, they both have to be true to get a true with an AND. Now, if we had an 8, we said we want to continue looping if it wasn't an 8 or a 9. Yes, so we want the AND then. Sorry. confused myself there. So we got an 8, so we want to stop. And so it comes out false. Where if it was neither of these, then we'd get a 1. Sorry. We want the or. We want to continue while it's not an 8 or a 9. So an 8 will get us out of the loop. It's the end. Sorry. Yeah, no, I confused myself as well. Because if we use an or, we're always going to get a 1. So it needs to be an and. Sorry about that. Let me just open a window. It's getting really hot in here. All right. So let's have a look at this with our and. So, all right. Sorry, I think I've confused a couple of people, but this is what happens when you're doing it live. So let's have a look at the and go through it and explain why that's the correct way. All right, let me get rid of this. All right. So here with, let me just sort this out. All right. So here we want to say we want to continue while the input is not 8 and not 9. Meaning that if either of one of these is true, we get a 0 and the and comes out as false. Okay, so if I put a 9, I get a 0 on this side. Okay, and we get a 0. Okay, so we stop. But if I enter any other value, let's say a 6 or something, then we get 1, 1. Okay, and it'll continue looping because it's true. All right. Sorry about that. I confused myself a little bit. Does that make sense? Why we use an and there? If you're watching, please use the chat. Does that apply for all? What do you mean by does that apply for all? So if we had an or here, it always be true because it's always going to be one of the cases. Because if you put an 8, then that other one has to be true. If you put a 9, the other one has to be true. So with an or, it's going to always make sense. I mean, always be true. Is that what you mean by that question? So or is used when you want to continue if one of them is true. So that it makes sense with the other case where we want to say either an 8 or a 9 is entered. Because both 8 and 9 can't be true at the same time. But not 8 and not 9 can be true at the same time. All right, sorry for that confusion. It's really hot in here. I just opened the window, so hopefully that's a bit better. So we've got the next decision to make, and that's, do we use a do-while loop or do we use a while loop? And really, that question is answered by, is this a 0 to n case or is this a 1 to n case? Put in the chat what you think. Is it a 1 to n or 0 to n? Awesome. So we've got a 1 to n case because we must ask the user at least once which table they'd like to create. So you need to ask at least once. So we've got a 1 to n case. So usually the trick here is, in most menu-driven systems, it's going to be a 1 to n because you need to give the menu before the user can enter it for the first time. So when you've got a case like that where you need to show something at least once, it's going to be a 1 to n case. And so we are going to have a do-while loop. Okay, something like that. Then you can have your ands and ors and whatever you want inside here, okay, based on the choice. And in here as well, we're going to do this the simple way to keep this nice and modular. We're just going to put an if statement inside that to print out invalid input. Yes, you definitely could use a while loop. A for loop is completely redundant and it's not good use of the concepts taught, and you would lose marks for that. While this is not a suitable task for a for loop. There's nothing iterating. So for loops are used for iteration and counting. There's no iteration or counting here. If you were to change this problem so that, let's say, the user only gets 10 attempts before the program ends or something, then you've got iteration there, and then you would use a for loop. But this does not have any iteration, and hence this would not be suitable for a for loop, and you would lose marks on I can't remember what it's called. I think it's the last part in the rubric. We shouldn't be using a for loop. You need to know what all 3 loops are in this subject, and you need to know when they're appropriate. So if you're counting up or iterating over something or using arrays, then you'll use a for loop. This problem can be done with a while loop, but that just adds to one pointless check of our condition. And if we can reduce the number of checks, especially when we're doing our testing, that would definitely improve our code. And we guarantee entry for the first time, no matter what, even if there's a memory error. All right, so the other thing we need here is one thing that's hidden in the text here, which is this invalid input. Please try again. So as I said, it can be done with a while loop, but it is not the optimal solution. You'd still get the same amount of marks for this assignment with a while loop, but if you can do it with a do-while loop, you're setting yourself up well for the next assignment and the next couple of assessments in the labs. So if you know how to use it with a do-while, there's no excuse for using a while. And if you don't know how to use a do-while, then ask. That's what we can cover today. Or how to turn a while loop into a do-while loop is very easy. you just write do and bring the while down here. Okay. The other thing that it does is it means that you don't need this before the while loop, if that's the way you're doing it. So we've got this invalid input, so we can put a condition here, and if that's true, then we can just add another printf. Okay, and this condition here and this condition here should be the same. Okay, they should say something like, if the value is invalid, okay, so not a 1 or a 2, then print this and continue while it's not a valid value, a 1 or a 2. Okay. All right, are we all good up to this step? How do you use do while? So do while is exactly the same as a while, except for the while goes at the end of the braces. Okay, so here you've got while input not equal to 1, do the stuff between these braces. With do while, it's do and then while input not equal to 1 and then a semicolon. The only difference really for you at this stage is where it checks the condition. So you should be able to, if you've got your while loop, just swap that around and put that here, and it should work pretty much straight away if you've done it correctly. If it's printing it twice, it's probably because you've got the prints here and in here. If you add a do while, you can get rid of the prints up the top as well. Okay, so that's how you do a do while loop. All it does is it won't check the first time. Okay, it'll just do it once and then check. For a while loop, it will check and then do it. Okay, so you should be able to change this really easily in your code without causing too many problems. Just writing the word do instead of while at the top, and then after write the word while, braces, brackets, sorry, and then a semicolon. Okay. Does that make sense? The person asked about do while. Awesome. All right. So the reason that this is good now is that you can test this yourself. And this is modular, so we didn't worry about the rest of the problem. So if you got up to this stage and you wanted to test it, you could just add a printf down here to say something to see if you're staying in the loop or you've exited the loop. Is there a reference for using Vim? The internet? There's lots of references. Just go to Vim's website, I guess. All right. We don't have one ourselves. Actually, for Java, they have one, so I can ask if you want to use that one. All right, so this is all at this stage. Stop, 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 and check it works. Okay, so the good thing about the way we're doing it here, rather than one big block, is that we can stop and check it works. So you can just check if this works, all right? If you're going any further, then and this doesn't work, then you're writing code blindly, and we never really want to do that. Okay. So once you've got your do while loop or your while, if you really insist, you've got your printf, you've got your scanf, you've got your if statement, and that works, then continue to the next part. Okay. Are we all good? I'm hearing less yeses, so I need to hear some more yeses in the chat. Awesome. Right. Okay. So we can get to these two steps. Now I've skipped over step 7 and 8 here, and I'm going to kind of ignore most of these steps. I'm going to ignore all of this as well, except for the else go to step 9 part. So we're going to ignore all this, we're going to ignore all this, we're going to ignore all this as well. Okay. So here we have this, if the user enters 1, well, that doesn't really matter. I think that's weird. I think that's a mistake, but it doesn't matter. We'll fix that later. I don't think anyone's come across that yet. All right, so if the user enters 1, we do something, else we go to step 9, which is if the user enters 2. Now, when we have a case that's either one or the other, we call that a binary case. Okay. And when we have a binary case, we will use an if else. Okay. Some people have used if else, and that's because the previous step they haven't done modularly, rather they've looked at optimization. That's fine as well, but not the way we're going to do it here. A switch case is kind of pointless for a binary case. It's a lot of work and computation for something that's literally if or else. So because of that, I wouldn't recommend using a switch case here. Okay. So it's definitely going to be an if else. And there's only 2 options, so it's an if else. As I mentioned, if you are going with just making it one big block, then you might have an else if in there as well. But for our example, we're going to stick with the modular approach and make sure everything's working. And so we're going to use an if and an else. All right, so if the user enters 1. So we've already validated these inputs. Now I can't remember what I called it. I think I called it choice. So I'm guaranteed here that it's a binary case because I know 100% for sure that it's going to be a 2 and it can't be any other value because of the values that the user entered. Okay. So I don't need to check it here. Okay. Adding an if. Now, one common error I do see students doing is they'll add an else and they'll put a bracket here and they'll say choice is 2 and they'll get a funny error because it's not an else if. If it's a binary case, you don't need that. Okay, and you never have else with a bracket after it. Okay, so if you are getting errors around your else, that's one common area that a lot of students get mistakes. All right. Are we good with that? Turtles, if you're good. No problem with if else step. What's the question? No problem with if else in this step. I don't understand the question. You've got question marks. Is it a question or a statement? Okay, one turtle. All right, we'll wait for that person to answer and we'll just continue for a little bit. So for this example, let's just have a look at this first if statement. And we're going to have a chat about a couple of things here. This is fairly simple, but there's a couple of things that we do need to consider now that will make it easier for us in the long run when we're going to have very large data types and quite numerous data in our program. And this is scope. So we said something like if choice was 1, then we're going to do a bunch of stuff. Else, we're going to do something else. Okay. Now, in here, we're going to have variables that only exist in this if statement. And if they only exist in this if statement, they should only be declared within this if statement. And that's really important because it means that once this brace ends, these variables we actually lose access to and we don't have to worry about them. Okay, if you've declared it up the top, it actually makes it a lot harder later on when we're testing. So if we know that our variable is only going to exist or be used between these two braces, then we should declare them there. So for step 6, 7, 8, we've got 3 variables that we need, and they're only going to be used within this if statement because we're going to have other variables here. So let's have a look at this. So we want the starting, the ending, and the step size. Okay, so this is degrees, so I might just, now they're all integers. So here I would create 3 variables, making sure that the names are suitable. Okay, so I've got start C, say end C, and then step C or something like that. Okay. Actually, I'd probably call it step Celsius. I might make it bit, or step. I might call it Cell. That's a little bit more descriptive, whilst abbreviating. Okay, I'd call it something like that. But you notice that I declared them within the braces. So you give them a name that suits you, but they should include these definitions of what they're actually doing. And the brief has given you kind of a guess of what the name should be. Okay. Now, this is something that I've noticed a couple of students doing, and this is not what we want to do. So if you use this as a starting Celsius, then it shouldn't change. The value should be, once the user enters it, it should stay that value. We need to keep the definitions of the names that we gave the variables. Don't start using variables called something for something else. So for example, if you have a variable called number of cats and it's 4, and then you decide number of cats, I'm going to reuse this for the number of dogs, and you put 8 in there. You are going to make your code unreadable. Okay. Oh, whoops. Number of cats again. Okay, but this is relating to dogs or something. Don't just reuse your variables. Try and keep consistency with the name. Now, from there, we just have 3 printf scanf pairs. Okay, and we usually see these things in Printf, Scanf prayers when we're entering values. Now, here we've already seen you validate once, so we don't need to see it again. So you can assume that the user will always enter a correct value. Okay, so don't worry about validating, don't worry about invalid values. We're not going to test invalid values on these ones. We will on the one above, the 1 or 2, but these ones you can assume that you'll always get a correct value. Okay? So you're going to have printf scanf times 3. Okay. Okay, so I think that brings us to the end of that part, and then we can go on to the for loop, which I think is probably one of the most important parts, because a lot of people do this wrong. So because it's been an hour, I might just have a quick 5-minute break. And just grab some water and stuff. All right. I'll be back in 5, or maybe even less. If any of this doesn't make sense so far, just put it in the chat while we wait. Just turn the mic off. All right, so I'm back. Sorry about the birds. This room's incredibly hot. I had to open the window. So I just got a question about commenting. So do we only comment once about the purpose of the assignment, or do we comment on different things? And that's an excellent question as well. So someone asked about commenting. So the majority of your comments are going to be at the top of your code, but significant lines should be commented. Things like if the units aren't known, or if you've got a line of code which isn't easily understood by the reader. So if I see something like we saw in this week's lab where I had int input force is 6, the only comment there that I can think would be appropriate is newtons. okay, because I can read the rest. I can see it's the input force, I can see the value 6, and I can see it's an int. The only thing I can't see there is the units. With the maths, one way you can apply this is, let's say you've got some complex formula. Let's say you've got, I don't know, b divided by c plus x times x, ORed with x times y or something. What you can do in your comment is you can have a list of formulas and just refer to them. And then you don't need to put huge comments in your code. So up the top, you might have a list of formulas and then just list them. And then you can just refer back to them. And then it reduces how much comments you need in the actual code. And that's one way of reducing the amount of really big, long comments in the code. You don't really want huge comments in the code. You can have them if you really find it necessary, but short little comments are nice in the code, and then something descriptive at the top. The second question is indentation. So we talked about this in week 2, but if you go to your lab reference guide and go down to the bottom, you'll see this indentation style that we're using in this subject. This is called the Ullmann's indentation style, and there's a Wikipedia page there that explains it in a little bit more depth. But I put an example here. Basically, when you have one of these braces, you move in one tab, okay? And when you have one of these closing braces, you move back one tab. So what you should see is hills and valleys in your code based on where these braces are, okay? And these hills and valleys describe the code to a reader that's experienced with reading code. Having stuff flat makes it really, really hard to read, okay? So you can see every time I reach one of these braces, I've moved in. I reach another, I move in. Keep going down, reach another, move in. I have one that closes, I move back. I have one that closes, I move back. I have another one, I move out. Okay? So if you just follow that rule, Notepad++ will do it automatically for you, but it can be hard to get used to because you're used to programs like Word and stuff like that. But basically, the other trick is that in Notepad++, you'll see these dashed lines between the braces. There shouldn't be anything on those lines. The code should be here. Okay? So this should all be empty. Okay? This should all be empty. And this should be where your code is. Okay, and the distance between there and there is one tab. Okay, does that make sense to the person that asked? And then we'll move on to the for loops. I don't know why I'm rubbing that out, but I'll wait till that person responds and then we'll move on. Awesome. Cool. All right. So now we get to this point here. Now, all right. So the for loop is a really important concept in this, well, in most programming languages. And basically it's used for iteration and counting. So if you haven't seen a for loop yet, it has the style of for and then braces, like our while loop, but it has a little bit more power here. So you'll have 2 semicolons here, and you'll have the initialization, the condition, and the update. Now, this can get kind of confusing, because of the ordering of these. So I'm just going to call this 1, 2, 3 for now. So how a for loop works is we do 1, then we check a condition 2, then we do the body of the code, which is this part here. Then we go back up and do 3 and come to our condition again. Now, this here is basically what a for loop looks like. Now, you'll notice that this one, number 2, is a square, and I've written true and false there, T and F. So what this means is if this here is true, then we keep looping inside of here. If it's false, then we exit and we go below it. Okay? So one common task of a for loop is counting. So let's just do a simple example of that. And I kind of want to keep that on the page. So I might just move this across a little bit. Beautiful. And I'm going to grab my pen. So I'll start with the most basic example. I'll use blue. So I've got int I. Now, for anyone that's used C99, or they've used a different programming language like Java. I see a lot of students that do OOF do this. In ANSI C, you cannot declare the I inside of this bracket. Okay, so anyone that's doing Java, just be careful about that. All right, so I'm going to initialize I to 0. I'm going to continue this loop while I is less than 2, and I'm going to increment I by 1. And then I'm going to put a printf here, %b. I might put something else in there. So I'll put a colon in there, be different. And then I'll put my I. All right, so let's have a look at this loop in action. So why is that not green? Oh, whatever. All right, so here we have our I variable. Okay, so we're currently here in the code. And then we get to this for loop. The very first thing that's done is 1. Okay, and this says I is 0. Okay, this only happens once. Okay, as you can see in this diagram, I should probably put some more arrows so you can see clearly what's happening. And then we get to 2. Okay, and we ask, is I less than 2? Well, is 0 less than 2? Yes. So then we go into the loop. So we go into the loop and we print our value. So we print 0 and a colon. We then go back up, but we don't go back up to 2 or 1. Rather, we go back up to this 3. Okay? And this says I increments by 1. So when you say I++, that means +1. Okay? And there's a little bit more of a definition if you're interested, and you can have a look at that on the YouTube videos. I won't go through that now because it's not very helpful. If lots of people are confused by that, we can go through that in another help session. So I gets incremented by 1. Then we go back to 2 and ask the question, is 1 less than 2? Yes. So we go into the loop and we print 1. We come back up to 3, we increment by 1, and we ask, is 2 less than 2? No, 2 isn't less than 2. And so then we continue down here, right? So does everyone understand the basic format of a for loop? Okay, now what I do recommend, now this isn't a very good diagram, but you can get a good diagram from LMS. Why is my LMS gone? So if you want a good diagram for your reference, maybe to print off and put on your wall or whatever, we've got a collection of diagrams. Let me just get LMS open. If you go to resources, you'll see all these flow diagrams, and the third one there is a for loop. Okay, and you can see a basic example with a for loop and the code next to it. Okay, so you can see the I is 0, the I less than 4, the I incremented, and so on. Okay, so all the little diagrams are here. If you need them, you can have a look at a do while, you can have a look at a while, and we'll be using these when we get to the exam, because you'll be doing flow diagrams and flow charts in your exam. Okay, so if you want, feel free to print them up, turn them into a poster or whatever you want to do with them, but they are there. Okay. All right. So if everyone's good with for loops, the general for loops, this kind of for loop, just say yes or put a turtle. Cool. I think we've lost some people, but we've still got quite a few. All right. So now we get to this for loop, which we've got to be careful. And I've noticed a couple of students doing some strange things with these for loops. Now, there's two ways you can go about this. And I'm going to not do the example that's here. I'm going to introduce my own example. So I instead want to print out, let's say, just to make up a formula, let's say f of x is 2x plus 4. Okay, so I want my table to print out x and then f of x. Okay, makes sense? And then I don't need to reveal too much about the answer. So with this, I'm still going to have my start, but I'm going to call it start x, end x, and step x. Okay. I'm also going to create another variable. Now, I could use I, but I prefer not to because I'm not really iterating here over something. I can show you an example where we use I properly for iterating over x. But for most of you, you'll actually be changing the value of x or changing the value of the Celsius. So I'm going to call this variable instead because that's what we're doing. I'm just going to call it current x or current degrees Celsius. And this will help in understanding what's happening here and also help with the readability. If you are using I, okay, if you're using I, make sure to declare it here and here. Don't declare it up above main. It has a different meaning between here and here. So it should be declared within each if and else if you are using multiple I's. And in this assignment, we should not be using the variable name J. Okay? If you're not sure why, ask, and I can answer that question. Okay? So we shouldn't see a variable called J at all in this assignment. All right. So this for loop here, I'm going to say something like, so imagine these are all declared. I'm going to say something like current x starts at the start of x. Then I'm going to say I want to continue while current x is less than, I'll say less than or equal end x. And I want to say current x plus equals. So this here is called a compound statement, step x. Okay. All a compound statement is doing is it's combining. I might write that a little neater. I need some more room. Let me put that up there. Let me move this down a little bit. I'll neaten it up. Yep, cool. Now I'm on the wrong layout. All right, I'm going to neaten this up. Current x plus equals step x. I really shouldn't say plus equals, but you get the point. So this is a compound assignment. So all this is, if I've got plus assignment, all I'm saying is, let's say I've got a and a 2 here. All that is a becomes a plus 2. Now, if you haven't heard my other videos or streams, this is our assignment operator. Yes, it's hard being in the scientific or engineering field because you're constantly switching between maths and programming, and so often you'll accidentally say equals here. It's normal, don't stress about it, but just try and think of this as assignment in your brain. I use the word becomes, okay? And so if you hear me say the word becomes, I'm talking about this symbol. And the reason I use becomes is because it's a bit easier just to say a becomes the addition of a plus a and 2, okay? All right, so here, this is nice for reading. I can go for the current starts at x, whilst current x is less than the end, and we want to increment current x by step size. Okay, I haven't changed the definition of start, end, or step here. I've noticed quite a few students have actually changed the value of the start. So they've done something like this, and this might seem redundant, but I see it quite a lot. So they'll use their start x as the value that's changing, but how can the start be changing? That doesn't make any sense. The start should always be 0, -2, or whatever value is there. Okay. So that's something that you need to be careful of. Don't change the definition of stuff. Like that. Right. And then inside of here, I'm going to declare another variable called float f of x. Now you'll notice that I'm declaring this variable here inside as a for loop. This is where it should be declared because this is the only place it's used, is within inside of the for loop. Same with this. The degrees Fahrenheit is only used within the for loop, and so it should be declared within the for loop, not anywhere else. From there, I'm just going to put my formula. Now, as I said, this is my formula, not your formula that you've got. And I'm going to use current x plus 4. And then I'm just going to do a printf and make So the question about what if the temperature is more than 3 digits. So if it's more than 3 digits, then it's going to start shifting across. And you can play around with this and see it happen. And you can see the limitations of our specifiers. In cases like that, where you want to keep the whole thing still formatted, you would probably have to check manually with an if statement. If the value is larger than something, then you use a different format specifier. But for this assignment, we're not too worried about that. All right. Are we good here? Yes, yes. If you want to put it directly in the printf, that's fine. Depending on how complex the formula is, sometimes you won't want to do that because you want to make it testable. But for this one, as it's a short one, yeah, you probably do. You can get away with putting it inside of the printf. It's up to you. It's probably a bit safer to have it out because then you can test it independently, but it's a little bit more optimized putting it inside the printf. So up to you. I'm not too concerned there. Now, what else is going to do? Okay, so I can show you an. Actually, I might do that later. I can show you an I version of this where you'd use an iteration, but I might show that later because it's a little bit more complex. Now, one thing I also want to mention about the formula here is we have something, I can't remember. Where's the assignment sheet? We have 5 divided by 9 and 9 divided by 5 in our formulas. Now, there's two ways we can go about this. Usually, if we've got arithmetic in our code, you can pre-calculate that. Sorry, if you've got arithmetic with literals, you can pre-calculate it. Okay. Now, the other thing is, if you know that the thing next to it is going to be a float, then you can preempt that as well. Okay, so you can write something like 5.0f or just 9f. It's up to you. Same with division. If you know that one of these, let's say you've got a variable and I'm going to divide it by 2, and I know a is an int, then I can just add this 0.0 to make it a floating point. Okay, so if you are getting 0 for something like this, that's probably why. Okay. All right. Cool. All right. Is that making sense about the assignment? Have we got any other questions so far about the assignment? And then I'll go through the rubric. So while you ask questions, let me get the rubric ready. Seeing lots of totals. That's good. Find the empty spot. Grab the rest. formatting of the table. Values presumed to be correct. Therefore, we've got that one there. Okay, I'll put that over there for now. It's just too big. All right, cool. All right, so once again, double, triple, quadruple, check that you've got your name on your assignment. It says student number here. That's the most important thing for us. So the actual deductions off your student number. If you accidentally forget your name, I'm not too concerned. If your student number's not there, it makes it really, really difficult. So if you don't have your student number there, you will lose 100% of the marks. If you don't have the password, you'll also lose 100% of the marks. We've made the password extremely simple, easy to implement, easy to put in your code, so there should be no problem with that. The other two things we've already mentioned, which is go to and includes header files outside of standard IO. Okay, so nothing else. All right, now this assignment we haven't implemented what we decided to do from the start with the labs and the rest of the assignments. You'll notice if you have a look at assignment 2, every single criteria requires that the code compiles. Here, because it's the very first assignment, if it doesn't compile, you automatically lose 16%, but you don't get the 0. Where in the second assignment, if it doesn't compile, depending on the part that you're up to, you can lose a significant amount of marks. All right, so let's have a look. So first things first, that your name, number, and assignment is correctly formatted. That includes the stars. Okay, if you don't put the stars in, then you automatically lose 4%. Okay, so it's easy marks for that. The next one is that it compiles. Now we're also looking for warnings here, so make sure that you don't have any warnings when you submit. Okay, so if you've got lots and lots of warnings, then you need to fix them. If you're not sure what they mean, just chuck them up on the forum and I'll get to them. Okay, you don't need to put the code, just the warning. If you don't know what go-to is, don't worry about it. Okay, that should only apply to students that either are trying to grab random bits of code off the internet and hope it works, or if they've done C before and used very bad practices for very simple code. So if you don't know what it is, don't worry about it. We can talk about it later. I don't think it's really necessary to talk about now. All right, the next one is the logic appropriate? This is just about understanding the problem. So obviously, if you use different values than what it's telling you to use, if you're not able to ask the user a question, if you forget to ask the user but you've got the inputs. So this is just your logic. So a simple logic thing, do you ask the user the question first and then scan, or do you scan and then ask the user a question? Okay. No, we don't want the compiled program. We've got no use for it. We just want the source file. The next one is, are inputs and outputs understandable? This means that the inputs, well, firstly, the outputs, this should be easy marks if you just follow the examples. This is about asking the user which values which table they'd like, and the 3 questions of the start, end, and step size, and just making sure that you can actually get them. If there's lots of errors in that, you'll lose marks there. Suitable comment at the top of the code is worth 10, and comments throughout is worth 10. However, if you are referring to the comments up here, we'll still give you the 10 marks here. So as I said, if you've got a formula list or something like that and you're referring up to the top, we will consider that part of the commenting here. Okay? I'll talk a bit, actually I'll do this right now. So somewhere in LMS, right? There's LMS. There's LMS. On the resources, there's a brief documentation guide, and that might help you with some of your commenting. But don't comment every single line, okay? It's not helpful. And the number and size of comments is not a measure of how well you've documented your code. So just by chucking huge amounts of comments does not mean you'll get full marks for comments. It's how well it documents. What information does the user need to know, considering this is a scientific problem? Okay, so think of it from that perspective. All right. Okay. It doesn't say the amount of comments in any of these parts of the rubric. It just says excellent comments. It doesn't say lots of comments or few comments. It says poor or excellent. It's not a quantity we're looking for. It's a quality we're looking for here. Okay. The tables, correct format specifiers, spacing, and new lines are used. Okay, so we did the printf last week. You should all be able to get full marks there. Are the values produced correct for Celsius to Fahrenheit? That's just simply us trying a bunch of different examples and seeing if we can get it to break. Same with Fahrenheit to Celsius. The step size, so starting, stepping, and stopping, that's checking if your for loop works correctly. Now, with all these, we are going to have our own examples and we're going to have our own test cases. It's not going to be the test case that's listed there. So do try other examples. Try your own examples, try random examples, test if it works with negative numbers. If you put 2 negative numbers in, the step size is always going to be positive, but try a whole range of values and see if it still works. Is the code correctly indented? We talked about that before. If you have some errors, we will take marks off quite a significant amount, just because we don't want to encourage you going on with this. And there's not much indentation in this code anyway, so you shouldn't have any indentation problems. Variables named appropriately, okay? If the variables are named suitably for the code and the domain, then you've got full marks there. This also goes with using your variables inappropriately. So if you've called one start and then you start using it for iteration, then you haven't named it properly. If you've got variables and they're named suitably for the code, meaning that I can understand what's going on because the names are reasonable. So if you called it start, stop, and step, that would be good for the code, but it doesn't tell me much about the domain. Where if I have a bit about the code and I have a bit about the domain, the Celsius part's the domain, the start and stop is in relation to the code. And so that's where you get your 6. If you've called them all A, B, C, D, or S for stop and X, and they're all in capitals and they're all over the place, then you'll just get poor naming. Are appropriate variable types used? So this was what I talked about right from the start. We shouldn't be using double for everything. We should use the type that's the smallest for the given problem. Usually default for C is for whole numbers, unless you know, go with int. And with floating point, default go for float, unless you know it's going to be a lot larger. And expressions and concepts taught are used appropriately. That's like using a for loop for a menu-driven operation. You wouldn't get full marks there. Okay, we talked about that from the start. For C, we prefer words in lower. So, do this on here. So, variable names in C, we prefer lowercase, separate words by underscore. Okay. I know some people that are doing object-oriented will be doing both camel case and C, and it can sometimes be difficult. But this is the preferred way that we will do it in C. And I will accidentally go between them as well, but it makes it easier to follow this standard in C. Are there any other questions about the assignment? Okay, so I'm not going to go over the other one because I think I've given you most of the information about the assignment. I've told you an approach. I haven't given you the full answers. You'll still need to play around and work out the formulas and stuff like that, but you have the basic structure there. Once again, I want to see what you know. I want to see what you don't know so we can help you out. It is individual. We've already had problems with the labs and we're dealing with them right now. So we shouldn't see huge amounts of similarity. Yes, we're aware that the codes will be somewhat similar, but they should not be exact copies or very close copies. We're expecting probably about, at worst case, 85% similarity. And that goes into logic and a whole bunch of other things. So make sure you're doing your own work. We want to see what you know. If we don't see what you don't know, you likely fall behind. So be honest and don't copy whatever you do. So with the structure that we've got some main. We've got, I need to be able to draw straight lines. We've got do while. We've got our if. We've got some questions to the user. And then we've got our for loop. We've got our else. We've got some questions to the user. And we've got another for loop. Okay. I know some people have done it a slightly different way, where they've got everything inside of a do while. But especially for beginners, I would definitely recommend this way. And if you are planning on making this modular so you can modify it later, probably go with this way as well. On the submitted labs, because they're going to be marked in the lab, you might get feedback, written feedback, if there's something significantly wrong. Otherwise, you can speak to the person that marks you in the lab. I know some of them might have already been marked because we were doing some testing, but you'll still get a chance to ask the person who marked you. So we've set it up so that one person will be marking at the start of the lab, and so you can speak to them in person. It just saves us time. Because what we've found is that the majority of students don't read the comments. All they care about is the value. So it just saves us a bit of time by talking to the ones that want feedback. All right, is there any other questions about? Yes, it should. Yeah, so you should receive your mark in the week that you're doing it, usually in that class, as if we're um, up to speed and there isn't too many questions. The first few weeks are a little bit more difficult because we've got a lot of students. But once census day comes, we usually expect to lose a lot more students. And so things will become a little bit easier in the labs. All right, is there any other questions about the assignment? If you're all good, put a yes or a turtle. Then I might have another break and then we'll go on to next week's stuff, cover the lab for next week, unless there is any other questions about the assignment. Good. Okay, I might need a new sheet. Okay. All right, awesome. So what we'll do now is we'll have another quick break. And then we'll start having a look at this week's lab, unless there's some specific question that you've got. So I'm just going to take a quick break and we'll start that. So I'm trying to take a break each hour just because it's a lot of talking. So sorry, you just need to break it up a little bit. So let me check my phone. All right, if you're still here, just let me know, and we'll start having a look at the lab. Keep logging out of LMS. That's what I'll do. Lab week 4. Wow, we're already up to week 4. Blah, 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 blah. Oh, it's not that one. Right. So we've got task 1, which is a resistor calculator. Anyone that's done a little bit of physics, maybe in high school, you probably remember this. When we have 2 resistors in series, they just add up 1 plus 2 plus 3 plus 4. And when we have them in parallel, we multiply them and then divide them by their addition. Okay, and this is just for 2. A second assignment is sort of related to this, except we're going to be talking about impedance. So we're going to do an impedance calculator. The formulas are similar, except for we need to use complex numbers. So this is a good little start to this. So basically here, when you get a problem, it's a good idea to draw out the flow diagram. And that's what we've done here for this problem, is I've drawn out the flow diagram for you. So we've got this flow diagram here. And we've got this, and your flow diagram is part of your design stage. You can think of it like pseudocode. It doesn't need to be perfect. It's for you, for design. So whatever language works for you, as long as you use the right symbols and it makes sense, and others can read it and translate it as well. It doesn't really matter if you use yes or no here, or true and false, or 1 and 0. If you want to put a little bit of code in here, you can. You'll see on the examples under the references, there's one called natural language and one called code. This example here is written in natural language. We could also put code here if we wanted to. Whatever your personal preference is, when designing, you don't want to restrict the person too much so that their creativity and design skills can come out. And we don't want to spend too much time making these perfect because they're disposable anyway. We want to make the code perfect later, and we'll use these to help us make the code perfect. So don't stress if you did this and it doesn't look exactly the same, as long as it still has the same elements. So here we've got get value of resistors from user. Now that's combining a couple of things together. When we get something from the user, we also need to ask them. So usually, whenever we're talking about the user, we're usually talking about the pairs of Printf, Scanf. In this one, we're also going to use getCar, which we'll talk about a little bit as well. Get the configuration of the resistors from the user. If it's parallel, we're going to calculate using this formula, which we got from up here, and then we're going to display the equivalent value. If it's no, then we check if it's series, and then we calculate it. And if it's not series, then we've run out of options and we display an error message. So here, because we've got this error message, we actually don't have a binary case. Okay. If we got rid of this error message and we knew that the user was just going to enter one of these, then we could just do if else. But here we've actually got 3 options, so it's no longer a binary case. All right, so we come down and we get to the first couple of steps. All right, copy these across. Go across here. I made these a little big. Make that a little bit smaller. Hopefully you can read that. If you can't read it, let me know. So create a new file, give it a meaningful name. Now, these problems from now on until lab 5 will all have domains, so we should be able to easily extract a meaningful name from them. Okay, so give them something that relates to the domain. So resistance calculator, resistance something relating to the domain. Include the standard input output library and add the main function like we did in lab 1. At this point, compile. Okay, always compile at this step because it checks all your paths for all of your includes. And it also checks that main is written correctly. If it's not, you're going to get a huge list of weird errors that you could be tracing your tail for half an hour and just realize, oh, I spelt main wrong or something simple like that. So do that right from the start. Also add your return 0 and it'll make it a lot easier later on. Then create 2 variables, resistor 1, resistor 2 as a long. Remembering that long is an integer type, okay? So long belongs to the integer types. Now, when I write int as a capital, I'm talking about all integers. That's just part of my notation. And long is one of those. We also have equivalent, which is a float. Okay. And float is a floating point. And the 2 that we'll be using in this is float and double. We also have long double, but we won't really touch that. Okay. And we're going to initialize it to -1. Now, someone asked the question was why initialize it to -1? So if you can give a variable a value from the start, it makes it a lot easier later on when you're testing. -1 is a good value here because the result should never be -1 from these calculations because our resistors are always going to be positive. And so the addition or the multiplication divided by the addition should always come out positive. And so by setting it to -1, if we were doing testing and it came out as -1, we know that we've done something wrong and we can test that quite clearly. So when you can find a good value to give it from the start, even though you'll probably be overwriting it, it's better than just some random value in memory. You can do the same with resistor 1 and resistor 2 if you want, and that's a good way to approach that as well. You've also got a variable called configuration as a car. Now, I've given you all the names here, so that makes it kind of easy. Then you're going to add a printf statement that requests the user to enter the first resistor value. You'll notice that it says do not add a new line at the end. So with printf, from the first couple of weeks, you've probably got used to putting the new line at the end. But if you want the user to enter something on the same line, don't put the new line, and it means that the user will be entering. So let's say I wrote enter. It means that the user will enter their text from here. Okay. If you put the new line, then they'll enter on the next line. Okay. So that's just a trick so that they enter on the same line that you're writing. which is usually how you'll see forms and stuff. If you've filled out any forms on the internet or ask for your password and email, it'll usually be something like email, and it'll have a box next to it, not below it. And so this is a nice way to format it. All right. Then we continue and we get the values from the user. Here we're using the format specifier LD. We've also got this ampersand. As we've said before, don't worry about what that means right now. Okay. It's quite a complex topic, and we'll get to that later on. But we don't need to worry about that. In terms of the LD, you can have a look at the basic format specifiers and then answer the question based on that. Okay, so there's a little question there that says, explain why %LD. Okay. All good up to that step. I don't think there's anything too difficult there. So if you're all good, yes or turtle or oops. So I'm just trying to get an image of the next part. Yes, we still got quite a few people. That's excellent. All right, so now we get to the next part of the lab. Down a bit. Wait, we're going to run off the page soon. All right, so repeat the above 5 and 6 for the second resistor. So entering the value, getting it from the user. At the printf statement that requests the user to enter the configuration of the resistor. Do not add a new line at the end, so we're doing the same thing as before. We want the user to enter straight after we write the thing. We then get to this part here, and this is a little bit confusing. I'm going to do the fast version of this. I have got a video on standard in and get car on LMS if you want the longer version of this explanation. So we've got something called standard in, okay? And you can just think of it as big, long collection of stuff coming from the user, okay? And so the user enters a value, let's say the first resistor, they enter as 80, and you'll know that they press the new line character because they have to press enter to register the scanf. So for anyone interested, scanf is blocking, and so we need that new line. All right. Now, these are all characters. We're just entering characters, but the scanf, because we give this format specifier, it will turn it into the value 80, okay? So it'll become 80 as an integer and no longer be two separate characters. Now, with this scanf, it's looking for the first int it can find in standard in. So it starts from the start, looks, and finds this 80, okay? And then it'll take it off, do its conversion, turn it to 80, and then store it in resistor 1. Now, when it takes it off, it's gone, okay? It leaves behind the new line because that wasn't read, because that has nothing to do with the LD. Okay? It has nothing to do with the integer. Now, what's powerful about this is when we go and enter our second resistor, that new line is still on that buffer. But let's say we enter 60 as our second resistor. Okay, So what happens here is when the scanf activates, it looks for the first integer so that it can convert it and store it. So it looks at the first character and goes, no, you don't look like a int at all. So I'm going to skip over you, and then I'll keep looking. Oh, a 6. That looks like it's part of an integer. Let's keep reading. 0. Yep, that looks like it's part of an integer. And we stop there. Okay, because the next one doesn't look like an integer. And it takes everything off, but it stores the 60. Okay, so it takes that new line off at the start as well. And if you accidentally entered a comma or something like that, it would also take that off. Now it still leaves that new line at the end. Okay. And so it takes everything off, but it doesn't take off that new line at the end. Now, if we use, and this is what you've got to be careful of, getCar or %C in a scanf, it will grab that new line. Okay, and if it grabs that new line, that could be bad for us. So here we've got a getCar and then another getCar. If we didn't have this one, as soon as it reaches this question, are the resistors in series or parallel, this getCar gets called, and it has a look. Oh, there's already a character here. Okay, configuration is new line. Well, that's not what we wanted. We didn't want our configuration to be new line. So if you've got a scanf or a getCar before a getCar, then you usually want to. I didn't realize I was writing on the same layer. You usually want to get rid of that new line. Now, there are multiple techniques, but we're going to go for a simple technique for now. Okay. And all we're going to do is call getCar, but we're not going to store the value. Now, we know that there is a new line sitting there. There has to be a new line sitting there. Okay, because we had a scanf before it. Okay, so we know that there is a new line there, so we have to call this single getCar that's by itself. Now, if there wasn't a scanf or another getCar before this, then it would be empty and it'd be waiting for the next character to be entered. But because we know that there's a scanf beforehand, we need this. If there wasn't a scanf before this, we wouldn't need this. Now, we saw, I think, previously on the videos that you've watched, a little bit about functions. Functions, actually, I'll do it this way. Do it as a box. Functions require something to come in or nothing, like getCar, and then they might return something. Now, we can ignore that return value by just not storing it. Okay, and you can see that here. We've got no assignment here. So we've called the getCar, we've got the new line, and then we've gone, don't care, got rid of it. Okay, so this getCar here reads that and then gets rid of it. Okay, and we don't do anything with it. And what that means is that when we reach this point, we've got configuration becomes getCar, it will get the next character entered, which will be, let's say, S, and then a new line. Okay, so if we're going to ask this question again, we'd have to get another getCar. Okay, so this getCar here gets that S. Okay, and now it'll be removed, and we only have a new. Oh, we have a. No. Come on. Why don't you sit where you need to sit? There we go. So we only have a new line left there. Now I know this is a bit confusing, but this getCar is needed if you've got a scanf beforehand or another get car beforehand. Okay, so it expects a car, it shouldn't wait for a no, so if it expects a car, it will still wait for the new line. It's a blocking function, so it will wait. You can have it so that it doesn't, but you need other libraries. Standard IO doesn't support that. So get car will wait for the new line, which can be bad. And this is why you may have problems with get car, because you have to assume that the user's only going to enter one value. There's ways around it. If you have a look at some of the videos from last year, that was a bonus that we did in the assignment 1. So it can be averted, but I won't cover that for now. All right. Does that make sense? Or is there any questions about that? I know it's a little bit difficult, and there is a bit of a longer video there, but you're getting kind of the idea that we've got this buffer here, and that's where all the stuff's coming off. And it's only reading, when it reads something, it removes the stuff from the buffer, but it might leave some information there. So if that's making sense, just let me know. Okay, and it's a good idea. Try it without and see what happens. And that's one really good way, and that's one good thing about C, is that we can experiment. So you can try it with it, you could try it without it, you could try it after. You could try store that value and print it out. All right, awesome. Awesome. All right. Then we've got the conditional statements. So we've got if, else if, and else. And here you'll notice that we've got an or. Okay. I know I talked about this earlier, and I got confused about what problem we're solving, and I confused myself. But here's a nice, clear example. If configuration is a P or an uppercase P, then we go here. It has to be an or because it can't be both lowercase and uppercase. Okay. Else if it's a lowercase s or an uppercase s, then we go here. Now the P stands for parallel and the S stands for series. All right, let me go copy the next part. When we're nearly done with that question, then we can talk about the second one. The second one's a bit harder. All right. All right, so then we get to, in the first two conditions, add the appropriate statements to set equivalent to the correct value. Okay, I think given I lost my problem. It's somewhere up here. Given these formulas, you should be able to write them. Don't forget, this is something that a lot of students have forgotten. There are implied brackets there, so just be careful about that. Okay. The other thing to be careful about is that R1, R2 are integer types. Okay, so I don't even know where my drawing went, but they are integer types because they're long. Okay, so you might need typecasting here. Hint, hint, because we've got division. Okay, so that's another hint. Where are we going? All right, in the else statement, add the printf statement to print the following input is incorrect. Add the printf statements for the following two outputs in the correct location in your code. The values should change dependent on your input. So here, this can be done in a couple of different ways. You could add more if statements if it made you feel more comfortable below these if statements, or you could use the original if statements to print this out. Noting that it's printing out a different word down here. So you've got series down here and parallel down here. Why can't I draw on that layer? So you've got series and parallel. Okay, so what it's printing is dependent on some condition. So you could possibly put these into these conditions, or you could just add another if and else statement if it made you feel a bit more comfortable. Okay, and that's the first task, and that shouldn't be too difficult. Is there any questions about that first task? The second task is a little bit intimidating, so we can get to that in a second. So, if it made sense, just let me know. Can we use a variable to hold series in parallel? Yeah, so you could use a flag variable. There already is a variable. So what you could do, if you wanted to, what have we got? I'm trying to remember what the variable names are. You've got configuration. Okay? And what you could do is, when you input it, you could force it always to be lowercase. So that's one way that you could turn configuration into a binary flag, whether it's series or parallel. And converting to, or uppercase, it doesn't matter which way, but you just forward. I'm repeating similar steps. Yeah, that's fair enough. If you don't want to do that, that's fine. The condition's going to be slower than another printf, but another printf is going to be more memory. So it depends on which optimization you'd like to go. The other option is, actually, I'll skip that. So the other option is that instead what you do is you modify this to capture this first, the else case, else. So I'll show you this because I think you're interested. So if you don't want to repeat multiple printfs, but also don't want to add conditions that are unnecessary, so this way you don't repeat printfs, but you have the exact same amount of conditions. So you'd write something like if else, and this actually reduces the number of, and let's say this is your parallel. I can spell. This is your invalid. And then what you do is you put a printf here that prints the equivalent resistor. So the things that are in common, the equivalent resistor value given in in that part. Then you write printf without putting a new line, and then you put parallel here, put series here, and then you do your printf by part. And then you put your printf here, which will be the last part of the sentence, which will be in %d, %f ohms. In %3.3f ohms. New line. And now you haven't introduced any new conditions whilst not repeating any printf. And so you've got the best of both worlds in terms of memory and speed. Okay. But really, like any option would work if you wanted to do it. But this is one way that if you've got if you've got a sentence that's got the same amount of things in it, you just break the sentence up. Where it breaks up, you just put the if and the else, and then you put that there. But you've still got this because you can do the calculations still here. Calculations. And so you don't need any new if and else. But that's a little bit more difficult than this one here. But that's a nice way to do it. Yeah, and I think you understand what I'm talking about. All right. All right. All right, so the next one looks a little bit intimidating, but the maths isn't as hard as it looks. It's just that the symbols are things that you haven't seen before, or might have not seen in a long time. So don't get too scared of what's here, because it's actually a lot simpler than it looks. So what am I doing? I've lost what I had. There it is. Do I need anything else? No, I just need to move this across. That's what I was going to do. All right. So what we might do is just go through the maths, and then you'll see that it's not as scary as it is. Let me just. Sorry, I just need to look at my phone. All right, cool. All right, so here what we're doing is we're converting between HSL and RGB. Now, most of you are probably familiar with RGB. They're basically a color scale. I'll probably show you one here. So here I've got this color, which is mostly red. I'll have lots of red. If I put it in the middle, I add some green and some blue. Okay. If I go to green, it'll have mostly green, a little bit of red, a little bit of blue. You'll also notice this HSL or HSB, which we're actually using the HSB. We've called it L here, lightness. Here they've got its brightness. But you can see that as these change, And so we're just doing a conversion between these. Okay. So these are just two different ways to specify colors. And the example that we're going to do is we'll do the example that's given. And we'll explain the maths, and you'll see that this big thing is not as scary as it looks. So we start with, hey, the names correctly. I'm just trying to find if I named it correctly. All right, cool. So we've got hue, which is 330. We've got saturation, which is 85%. And we've got lightness, which is 60%. Now, when we're dealing with percentage, we can just convert, or we can just divide it by 100. Okay? And that will give us our three input values. Okay, so we've got lightness in, saturation in, and our hue in. And now we just need to go through this math such that the output should be our RGB values. So let's go through the math, and we'll see that it looks scary, but it's not that scary. So first we need to calculate this C. So we've got C is 1 minus the absolute value of 1 minus L, 2L minus 1, close brackets, times S. So here we've got 1 minus 2 times 0.6 minus 1 times 0.85. Now, if you haven't seen this before, the absolute value, just if it becomes negative, it becomes positive. So if this value here is negative, it becomes positive. So if I have negative 4, it becomes 4. If I have 4, it becomes 4. If I have negative 3, it becomes 3. If I have 3, it becomes 3. So it just gets rid of the negative. Okay? Now, inside of that, we've got 2 times 0.6, so we get 1.2. And what have we got? We've got minus 1, and we've got, sorry. So we've got 0.2 there. So it's not negative anyway, so it doesn't matter. We've got 1 minus 0.2, which gives 0.8 times 0.85, which is going to give 0.68. Okay. We then get to the next one, which is a little bit more difficult, but still follows the same principle. It's all fairly simple arithmetic, except for this mod. Now, this, we've got the values. Should just chuck them in from the start. So hue is 330. Okay, hue is 330, and C is 0.68. Now, this mod is a special operator. This is a floating point mod. So mod means remainder, if you remember your remainders. So if I have, if I have 3 mod 2, I should get a 1. Here it's a little bit more interesting. Because we've got floating point, but we're going to let the computer do this job. In this case, it comes out as 1.5 minus 1, and then we've got 1 minus that times our 0.68. Now, unfortunately, the stuff in the absolute value, so those 2 straight lines have come out positive again, but if the value came out negative, we get a negative there. And adding that all up, well, solving that, we get 0.35. We then have M, which is a very simple formula, which is L, which is 0.6, minus C, which is 0.68, divided by 2, which gives 0.26. Okay, so that first part there we're going to have to implement in code. And with this, we're going to have to implement the absolute value. And we're going to do that ourselves. And then we're going to have a look later at some functions that can do that. The mod operator, because this is a special mod operator, it's actually called a floating point mod operator. We're going to use a function for this. Okay. For integer mod, we just use the percent symbol, which means remainder, but this is a special one. And the rest of the mathematics is fairly easy to implement. You've got minus, you've got multiply. That should all be able to be done in code. It's just these parts here that make it a little bit difficult. All right, we're all good up to that point with the maths. And then we'll get to this big, scary looking thing. But 2 isn't an well, firstly, this is maths. But secondly, the 330 divided by 60 gives a floating point value. It's not that well, this can be, but it's that this is a floating point value. I'm not writing code yet. I'm just writing maths. So we'll have a look at it when we get to the maths, and we will have to specify that 330 divided by 60 as a floating point. But we'll get there. But I'm not writing the code yet. This is just to go through the steps. All right. Now we get to this big thing here. Now, I know that it might look intimidating, but it's actually very simple once you start implementing it. So all it says is if Q is between 0 and 60, then we use this formula. If Q is between 60 and 120, then we use this formula. If Q is between 120 and 180, then we use this formula. So you can see that this is just a big if, else if, and so on. Now, with this, make sure you're using AND. Okay, so let's say our variable is called Q. So 0 less than or equal to Q and Q is less than 60. You need that AND there. You cannot join these up. Okay, you need the AND, right? So remember the number line. We're going in between there and there. Okay, so in this case, we're going to use, so let's say we've done all the other ones. We're going to use we're using the last one, sorry. We're using the 300 to 360. Yes, we're using this version. Okay, so this version here all that's saying is that this new variable called r dash becomes C. Okay, so we've got these functions that map to each other. Okay, so the R goes to the C, so whatever C is, 0.68. The G becomes 0, G dash, sorry. I don't know why I'm writing semicolons, so maths here. And the blue dash is X, which came out as 0.34. Okay, so I know it looks scary, but that's all it is. Then we get to this last part. You'll notice that this function and this function here, they map to each other through these commas. So we've got red equals, and it's equals in this case, because we're dealing with maths, times 255. Okay, so you can break these up into three formulas, okay, which should be 0.68 plus m, which is 0.26, multiplied by 255. And you do the same with the green, and you do the same with the blue. Okay, and that gives you 239.7. Okay, so your red would be 239.7. All right. So does this big thing make sense? And then we'll go have a look at it in code. And all right. Awesome. Okay. We'll be back in 2 seconds. With the error. See, I haven't forgotten this week. All right. Cool. Cool. All right. So this task here is starting to get a lot of maths. Okay. And the reason that at the start of the lab I give you an example is so at this point here, if you're not getting 0.68, then you shouldn't continue. Okay, because you can see that 0.68 is this is dependent on this, We're using it here, we're using it here, and then we're using it here. So your error will just keep carrying on and on and on. So with this lab, we're going to test as we go along. Now we've been testing in terms of compiler errors constantly, but now we're testing in terms of logical errors as we go. Okay, and this is going to be incredibly important because if you have a small error here, it's just going to carry right to the end, and you're not going to know where the problem is. And you're going to have to test everything. Okay, so this is going to be really important. Now, just copy this page over, move it across a little bit, copy this across. Screen. Oh, I've got it already. Oops. All right, so here's the first part. There's a couple of things here. Writing the whole code and checking for logical errors will make this problem difficult. Rather, we use the example above and check our solution as we go. If you do not do this, you'll likely have a hard time getting the correct output. There's a guide on LMS, but I've also this year put it directly into the question, which we'll see soon. The other thing that we're going to do is we're going to include another library, which is our math library. Now, this isn't a standard library. All the standard libraries start with std. This is the only non-standard library that we'll be using in this course. Okay. Now, when you use it, when you compile, you'll also need to add the -lm. Now, if you are using the backup script that I gave on LMS, you don't need to do anything extra. So if you're compiling with the backup script, you don't have to worry about this because it's already included. All right, so add the main function, declare the variables hue, saturation in, lightness in, red, blue, green, all as unsigned int. Okay. Now, in this problem, we only have positive numbers, so we are going to use unsigned. Okay. Declare the variables, saturation, lightness, both as float. Then ask the user for the hue and store in the hue variable. Ask the user for saturation between 0 and 100. Now you'll notice here that I've got this name here. It's called saturation in and lightness in. The reason for that is the user's going to enter 80, but we need to convert that to 0.8. But we also want to keep this value for later on, okay, when we're going to print. Okay, so we've got saturation in, but we're also going to have another variable later on called saturation percent or something like that. I can't remember what I called it. So that's the start. Then what we're going to do is we're going to test that that part worked. Okay, because if that part doesn't work, then we're pretty stuffed for the rest of the thing. Lab. So you'll notice these green bits here. They're an addition this year that I've added because I want to encourage this practice. So at this stage, you can validate your inputs based on the example above. Add the following code, compile and run, and validate that you're scanning the inputs correctly. So once you've done G, you can just add this printf. I've written the word check. You can write the word check or test or something that indicates that it's not part of the normal output. Rather, it's just to check if you've been doing it correctly. And then I printed out the variables and their values. So you can see here, enter the hue, 330, 85, 60, and then I printed these out just to double check that they're correct. So this is checking for logical errors. So if you, for example, presented the hue 330, 85, 60, and the hue came out as 330, the saturation in became 330, and the lightness in came 330, then you know you got to go back and fix it. Okay, as simple as that. This line can then be commented out once you're satisfied this part works. So with our code, if we don't want to include it anymore, we don't have to delete it just in case we want it later. And we want to see that you're checking for logical errors. So just comment it out once you're satisfied that this part works. We then need to convert the saturation into a percentage. To do this, divide the saturation in variable by 100 and store in the saturation variable. So I've just called it saturation. So the saturation and saturation in, if saturation in is 85, then saturation is going to be 0.85. Now, another hint here. Think about typecasting once again. As I said, typecasting is important throughout this whole subject, and we've got a division here. So just keep that in mind. And then lightness needs to be done the same. Okay, so we should have 2 floating values for those. Once again, you can test these and make sure they came out correctly, especially considering we've got some typecasting here. You might not actually need typecasting at all, but you might want to change your literal into a different type, and that's even better than typecasting. Okay, so you may be able to do it that way. So we talked about before we could specify things as 100.0 instead, and that would be a nice solution to that problem. All right. Are we all good up to that step? And you understand why we're doing this? If you are, just say yes, or a turtle, or a lizard, or one of those. Cool. All right. Now let me get the next part. Lab. Okay. So this is the part that a lot of students get confused by. And it's the very first formula. And we're going to do this manually. You can also do this using a function, but it's a good idea to understand these things done from scratch and then use the functions after. So here we've got declare variables C, X, temp, M, red dash, green dash, blue dash, all as type float. Now you'll notice that we're declaring them at this stage. We didn't need them before, so we're declaring where we're about to use them. And this is where all our math is going to start. And so we're going to need all of these. Now, temp is one that we haven't seen in our math, but we're going to need it for what we're doing here. So with our math beforehand, I talked about the fact that everything inside of these line brackets in mathematics is called the absolute value function. And basically, it converts anything negative to positive. Now, we don't have these in C, okay? So you cannot write 2 lines in C and it will do it. They'll be considered as binary ORs, okay? And you'll get an error, okay? Because there's nothing beside them. So we're going to implement this from scratch. So what we're going to do is, given this formula, we'll just calculate what's inside there first, okay? So we'll calculate that first, and we'll store that in the temp variable. Okay. From there, we're going to find the absolute value of this. So how would we check if a value is negative in C? And I asked that to the chat. How would I check if a value is negative in C? So we can just check if it's less than 0. Okay. So if it's less than 0, then it has to be negative. Okay. And if it's negative and we want to make it positive, then we can multiply by -1. But let's test our theory and see if that works. So if I have -4, is that less than 0? Yes. Multiply -4 by -1, and I get 4. Let's try this with another value, 6. Is that less than 0? No. -28. Is that less than 0? Yes. So we grab that value and multiply it by -1, and we get 28. Okay, so that there is doing our absolute value function. Now, you can go and research and find the actual function that does that. And that's a little bit of a bonus for you if you have time. Okay. So I put that here. The above step is perform the absolute value function as a learning bonus after you've completed. Research which function to use to do with this, the math library. That should be a lowercase m, but that's okay. So we should have something that looks like temp, that formula there. If temp is less than 0, then temp becomes temp times -1. Okay. And now our formula up here just becomes C. Now I'll do it in maths first. So C equals 1 minus temp times S. Okay. So you can easily put that into code, and this line of code I've actually given to you this year, because I know a lot of students got confused by this. Okay, so we can rewrite our formula. C becomes 1 minus temp times saturation. Okay, all we're doing was replacing that because we've already solved that. Okay. After we've done that, we can double check that because that was quite a bit of work and we don't want to continue if that's wrong. So just run a check on C and make sure that it comes out as 0.68, given the example that we have at the start. All right, are we all good up to that point? Now, I had to add this in because I know a lot of students get scared of this, but we are using C, which is a fast language, and so we want to optimize where possible. Yeah, so this is getting used to using if, else if, the math library, bit of math, testing. Yeah. So this is the first thing. We've finished using temp for the previous calculation, hence we can override it for the next part. So we don't need to create another variable called temp. We can just reuse it to calculate this part. Okay. Now, this one is a little bit more difficult. As I said before, the h divided by 60 mod 2 is actually floating point a mod operator. And so I've written this here. Standard C's mod operator only works for integers. However, we require floating point. To do this, we're going to use this f mod q divided by 6. One layer. I'll put another layer. We've got this here. Now, this 60 does need to be specified as a floating point or it won't work. And what you'll notice also is I've got this -1 here because I'm trying to calculate all of this at once. Yeah. Now, if you don't understand this fmod, don't worry. That's what it's there for. That's why there's a function there for it. You don't have to solve it manually. Let the function do its job. We're then going to find the absolute value. So if temp's less than 0, then multiply it by -1. So exactly what we did before. We then calculate this whole formula, considering that we've already solved this big part already. So the formula just becomes x equals c times 1 minus temp. Okay? And we've reused temp, and that's perfectly fine. Don't be scared to reuse variables. Okay? If it had a special name, then sure. But this is just a temporary variable for holding absolute values. So it's fine to reuse. Then we calculate m, which there's not much to that. You shouldn't have any problems with calculating m. And then we check that c and m, that should be x. There's a mistake. Whoops. All right, cool. Well, I picked up the mistake, so I get the chocolates. All right, I'm going to write that down somewhere. Step. Step U. I gotta fix that. Okay, so that should be checking X, not C. But I think you get the point of what it's meant to be doing there. So I'll go back and fix that. Then we get to the next part, which is our piecewise equations, which is this big, long, scary looking thing. Isn't that scary? It's just big. So we get to this part. So use if, else statements to select the correct values for red dash, green dash, blue dash based on the piecewise. So with this, you're just going to have lots of if, then 3 lines, which is going to be red dash becomes something, green dash becomes something. It's going to be very repetitive, and blue dash becomes something. Else if, and then the same thing for the next part, and so on. And red dash would become C here, green dash would become X, blue dash would become 0. For the second case, it would become X, C, and 0. Okay, so this can get confusing, and this is why at the end of this lab you should be trying other test cases because there's lots and lots that could go wrong here. The other thing is that this is actually not the most optimized way to go about this. So if you're interested and you finish early and there's not too many questions, we can go through a better way of doing this such that we have a lot greater efficiency and less comparisons. Or if we have time in the next week's help session and someone's really interested, we can look at a better way to do this. If you've done the subject ALG, you might be able to work this out yourself as well. All right. Does that all make sense? Have we still got people? All right. So then we can validate that. Then we get to the end. Where's the printer? Go up a little bit. Maybe find some empty space. 3 of you left. How many's in the thing? There's 13 watching. 3 in actually interacting. That's all right. We're gonna end soon anyway. Unless you have any more questions. But what was I looking for? I don't even know. Oh, it's already there. All right, so we can check that answer. Then we can calculate red, green, and blue using the formula. Now, I've already put it there. Well, all right, so here we've got 3 equations, okay? So you just break this up into 3 equations. So that's the first equation. That's the second equation. And that's the third equation. How do you write in the brackets of the if? How do you write the brackets in the if? Do you... All right, we can have a look at that in a second. Cool. So are you talking about these brackets? Yeah. Assuming you're talking about the brackets, not the braces. So let's do an example. Yep, cool. Okay, that's fine. So inside of here, I need to say H is greater than or equal to 0 and less than 60. But in C, I can't write it like this, okay? Because it actually will always evaluate to true. And the reason for that is that this here comes out as true, and it will come out as a 1, and then 1 is less than 60, which is also true. So we need to use an AND. Okay, so we say AND H is less than 60. Okay, so H can both be less than 60 and greater than 0, so we know to use an AND. So when you see your number line, if your number is going to be between 2 values, then you use an AND. If it's going to be 2 values either side of something, then you use an OR. Okay, so that would just go in here. All right, and you might use your variable name. I think it was Hugh or something like that. I'll write it as a variable name. Is that what you wanted? Yep, cool. All right. From there, we get to the very last bit, which is print the HSL values and the RG values to the user. There's an example on the sheet of how to print it out. So the other thing that you'll notice here, which is really important, we should not only test our examples. We should test lots of examples. So just try it with some random values. This is a HSL to RGB converter, so you can put whatever values you like in there and test that out. Now, the very last thing here is this thing here. As a learning bonus, convert the decimal RGB values to hexadecimal. Now, this here has confused a lot of students in the past, and it is one of the most simple things to do. You do not need any math to do this, okay? Remember that what's in memory can be read lots of different ways, okay? So I can take my value and read it as a decimal integer. I can also take it and read it as a hexadecimal integer. I could also read it as a character. So you don't have to do any conversion. It's just the way you read that information. Okay? If you're doing maths to convert it to hexadecimal, you're doing it wrong. That information is already in memory. We just need to read it the correct way. Okay? So really, it doesn't involve any extra math. It shouldn't really involve any extra lines than you've got. And it should just require replacing rather than adding anything. Okay, that's my hint. So if you are doing math to change it, you're doing it the wrong way. Any questions? Are we all good? I think we're all slowly disappearing now, so I might leave it somewhere there. Maybe over here. That's a nice place to leave it. Any final questions? Yeah, pretty much. How do you scanf? Scanf. So I'll just do the basics for what you need. If you want to do more complex things with Scanf, go have a look at the Scanf video. But for simple Scanf, so this is going to be some format specifier, and you can get your format specifiers off that reference sheet. So for example, if I was going to get an int, it'd be %d. If I was going to get a character, I'd do %c. If I was going to get a floating point number, I'd put %f. Now, one thing that I will mention about that, you cannot do 0.3f here. It doesn't make any sense. You can't force the user to have a certain amount of decimal places. The user can enter however many they like. So whatever format you want, and then your variable that you want to store the value in. So for this case, I might have float var, and then I'll have a printf, enter value, and voila, we get a value from the user. And that's basically, you're just changing this and this. For more complex examples, go have a look at that video. This is the most commonly used way that we're going to use it in the subject. So more complex examples include if you wanted to get two values at the same time, or you're getting characters. So if you want to go have a look at that video, it's on LMS, but otherwise, this is basically how you're going to use it probably 95% of the time in the subject. Here's LMS. Wrong subject. So week 4. Yeah, so on week 4, there's a longer video on Scanf just here. And that goes through some basic and more complex examples. But as I said, 95% of the time we'll just get one value at a time. There's also get car and standard in there. All right. Thank you very much. I think we'll leave it there. I think we've filled up the whole thing. No, we haven't. And I'll see you during the week. I think that was a pretty good session. I think we're all clear on the assignment and we're clear on everything. All right. See ya. Let me close it down.